So now on to digital signatures. Now, a digital signature is a hash value, which is here, which we just discussed. So it's the fixed length result of a hash function that is encrypted with the sender's private key to produce the digital signature or the signed message. So a digital signature is technically a stamp of approval for the signer. It is a provider of guarantee over whatever it is that's being signed. When something is digitally signed, it provides authentication because it's been encrypted with the private key, which only the person who has the private key can encrypt with. So that is the authentication. It provides non-repudiation because, again, the sender's private key is used, and it provides integrity because we are hashing. A digital signature could be used, for example, with software. It could be used for drivers within your operating system. It could be used for certificates to validate that all of those things are genuinely from the person that they claim to be from, and that the integrity of them has been maintained or there's been no changes. So if we go and have a look here at the Chrome install file and properties, and you'll be able to do this in any operating system or the equivalent of, and we look here under digital signatures, we click here, we can see already some details, and we view the certificate. What we can see is this has been issued to Google by VeriSign. So it's VeriSign whose private key has been used to digitally sign this software. Veracode is saying this software is legitimate and it hasn't been changed. So as it says here, ensures software came from software publisher, protects software from alteration after publication. To know that this digital signature is valid, we have to reverse the original process. So we have the digital signature here, or the signed message, or the signed software. You then use the sender's public key, in that case it would be VeriSign, to decrypt, to reveal the hash, which you can then verify yourself. You'll have a hash value for it that'll have been taken from the digital signature. You can then take the file, run it through the same hashing algorithm, and you compare hashes, and you can see that the software has maintained its integrity. But when it comes to software, this is all happening behind the scenes, and it's been verified without you knowing. If verification doesn't happen, you'll get warning messages, and you'll have seen these before. Here is an example of one. Windows cannot verify the publisher of this driver software. That means that it either does not have a digital signature, or you see how the Veracode was the person that verified that digital signature, that your operating system doesn't trust Veracode. And we'll go in later as to why you might trust Veracode or not trust Veracode when we get to certificates. Windows 10 has introduced new technology called Device Guard, which is a way of using digital signatures to lock down what your operating system will and will not run. So Device Guard will only allow certain types of signed files to be run. Theory being that then malware cannot be run, or rats or trojans, because they won't be signed. There are of course ways around this, which we'll discuss later, but Device Guard is another layer of defense. So let's go through this just one more time, because I think it can be sometimes a little bit tricky. So a hash value that has been encrypted with the sender or issuer's private key, that is a digital signature. It provides authentication, non-repudiation, and integrity. And if you encrypt something and also provide a digital signature, then you're also going to get confidentiality along with authentication, non-repudiation, and integrity. Digital signatures ensure that the software or whatever it is that you've got came from that person or that publisher, and it protects that software or that message from alteration after it has been published or sent.